Now that you already have mastered removing common factors to factor polynomials, in this video we will be learning to use formulas, particularly the square difference formula, in order to conduct factorization. The square difference formula is a formula that we have learned before. If you think that you need to go back and review that, I will be linking its video in the description down below that you can click into and review some information. Anyways, let's get right into the lesson. This is part 1 of our lesson, factoring using formulas. Part 2 will be using the perfect square formula in order to factor. So if you don't want to miss out on that, be sure to hit that subscribe button as well as the notification bell. The two learning goals of today is to use the square difference formula to factorize and to factorize polynomials by comprehensively using the common factor method and the square difference formula. So here comprehensively means that you can use both the common factor method and the square difference formula to factor. Introduction. As shown, a small square with a side length of b is cut off from a large square with a side length of a. The remaining parts are assembled into a rectangle. According to this process, what formula can you conclude? So this is reviewing our square difference formula. Here we have a square with a side length of a, and a small square with a side length of b is being removed. So here we move this portion over, as well as this section right here, which is the remaining parts after having the small square cut off, and we have this area right here. So this length is a meters and this length is b meters. Their shared width is a minus b meters. Out of this, we can conclude a squared minus b squared is equal to a plus b times a minus b. Each of these sides are using one perspective to describe and to express the area of this dark blue area. So, for example, a squared minus b squared would be this entire square taking away this part right here. And for this second expression, it is a plus b times a minus b. So it's all describing the same value and expressing the same value, just with different ways. Factorization with the square difference formula. What characteristics does a squared minus b squared have, and can you factor it? Well, we know that it is the difference between the squares of a and b. And here is the square difference formula. A plus b times a minus b is equal to a squared minus b squared. From the left side to the right side, this is the multiplication of whole expressions. Here, both of these parentheses contain one whole expression and they are being multiplied together. But if we switch this the other way around and we have a squared minus b squared is equal to a plus b times a minus b, the left side of the second equation to the right side of the second equation would be the process of factorization. As you can see, this fits with our definition of factorization, as factorization is just turning a polynomial into the form of the product of two expressions being multiplied together. The square difference of two numbers is equal to the product of the sum of these two numbers and the difference of these two numbers. So determine, can the following polynomials be factored using the square difference formula, and why? Now I want you to pause the video and try to determine this on your own. Let's look at the first one. This would be no, because this does not fit into the form of a squared minus b squared. But the second one here, it does, because technically you're replacing a with x and b with y. So x squared minus y squared works. What about number 3? This does not work because, as you can see, if you factor out a negative 1, it would be negative 1 times x squared plus y squared, which essentially is just the same as the first one. Using the square difference formula to factor, we are turning a polynomial into the form of something squared minus something else squared. So after removing the common factor of -1, this is really just -1 times the sum of x squared and y squared. This next one here can be factored by using the square difference formula, because if you think about it, it's the same thing as y squared minus x squared. What about this next one? This one also works because it is the difference between two squares. Here we have x squared, and if you think about it, 25y squared is just the square of 5y. 25 itself is a perfect square, which means that this is factorable. This can be factored into x plus 5y times x minus 5y. And for the final one, this is also doable, since 1 is also a perfect square, and this can be turned into m plus 1 times m minus 1. Let's do our first problem. Factor these two expressions. Pause the video and use the square difference formula to help you. This first one, we have 4x squared minus 9. We can simplify this into 2x squared minus 3 squared. A squared minus b squared. So here, 2x is the same thing as a, and 3 is the same thing as b. Now turning into the form of a plus b times a minus b, we have 2x plus 3 times 2x minus 3. Now for the second question. Here we have x plus b plus x plus q times x plus b minus x plus q. Now after simplifying, we have 2x plus p plus q times p minus q. And we can get this by thinking in terms of a whole. So what I mean by this is, instead of thinking of x plus p as an expression, we can think of it as one number. So this can help even if you decide to replace it with another variable. Say you replace x plus p with capitalized A and x plus q with capitalized B. So this would also be A and this would also be B. Now this can help you think in terms of a whole because an entire expression is being represented with one variable. So here is our method conclusion. Regardless of whether A and B represent numbers, monomials, or polynomials, as long as the decomposed polynomials can be converted into the form of square differences, they can be factorized using the square difference formula. So no matter if it's a number, monomial, or polynomial, and you can see if it can be converted into the form of square differences, and if it can, then you can use the square difference formula. Let's do some more training. Pause the video and simplify these two expressions. The first one, we have a plus b minus 2a times a plus b plus 2a. We can simplify this as equal to b minus a times 3a plus b. Here we can think of a plus b as its own variable. So here what I'm going to do is replace a plus b with x. So then we'll have x minus 2a times x plus 2a. This way, we can more easily visualize using the square difference formula since an expression has been replaced with one variable. So that's just applying our thinking in terms of a whole mindset. Now, our second question, 9 times m plus n squared minus m minus n squared. You can think of what is being squared. So what is being squared here? This is just the square of 3 times m plus n being squared, and this is just, m minus n being squared. So both of these expressions are the expressions that are being squared. After taking that out, we have 3m plus 3n minus m plus n times 3m plus 3n plus m minus n. Simplified, we have 2m plus 4n times 4m plus 2n. But if there is still a common factor after using the square difference formula, the common factor must be removed using the common factor method. So after removing both of the 2's from these two parentheses, we have 4 times n plus 2n times 2n plus n. Factor these two expressions. Well, as you can see in the first question, instead of squares, we have the variables being raised to the fourth power. But we can just first d-square that, take the square root of that, and have x squared squared minus y squared squared. So after that, we would have x squared plus y squared times x squared minus y squared. But remember, we can still keep factoring. After factoring once, make sure that it is fully factored, and if not, then finish the factoring process. So we can continue factoring, and our final answer should be x squared plus y squared times x plus y times x minus y. Unfortunately, if you just got this as your final answer, you're going to have to minus some points for yourself from that, because we want to get to the habit of factoring expressions to the very most extent. Now for the second question. We can first take out the common factor from both terms, which is ab. And then we have ab times a squared minus 1. So when factoring, usually you remove common factors before using the formula. And here we can still use the formula to factor a squared minus 1. So our final answer should be ab times a plus 1 times a minus 1. Here's our conclusion. Generally, common factors are removed first, and then the formula is applied. Factorization must be carried out until no polynomial can still be simplified. So in these two questions, we practiced our skills with both removing common factors and using the square difference formula. In a lot of problems, they are seen being used together. Let's do some more training. Factor these two expressions. Remember, the first thing we have to do is to take out the common factor. So for the first question, the common factor is 5m squared. And then after taking that out, the remaining expression in the parentheses would be a raised to the fourth power minus b raised to the fourth power. We can simplify that, and we have 5m squared times a squared plus b squared times a squared minus b squared. We continue simplifying, and this is our final answer. And for the second question, we can first group together a squared minus 4b squared and a plus 2b. After simplifying the first parentheses, we have a plus 2b times a minus 2b minus a plus 2b. And after that, we can still take out the common factor, which is a polynomial, a plus 2b times a minus 2b minus 1. So this is our final answer. So here is example 3. Given that a squared minus y squared is equal to negative 2 and that x plus y is equal to 1, find the value of x minus y, x and y. Pause the video and think about how you would solve this problem. Alright, so here is our solution. Since we can break x squared minus y squared down into x plus y times x minus y, then we know that x plus y times x minus y is equal to negative 2. Then we can substitute x plus y with 1, which means that x minus y must be equal to negative 2 in order to make this equation true. We can put these two equations into a system of equations and solve x is equal to negative 1/2 and y is equal to 3/2. Example 4. Calculate these two numerical expressions. Alright, so even here there is no variables, but this is just training you working with removing common factors and using the square difference formula. So removing common factors with numbers is something that we have worked on before, but this is combining its use with the square difference formula. So for the first one, we have 101 plus 99 times 101 minus 99, which is equal to 400. And for the second one, it would be 4 times, since 4 is the common factor, the difference between 53.5 squared and 46.5 squared. And then after taking that out, we have 4 times 100 times 7, which is equal to 2,800. So our method conclusion for this question is complex computation problems can be simplified using factorization. So factorization is not just for polynomials, it can work and make your calculations with numbers simpler too. Now we have example 5. Prove that when n is a whole number, this polynomial is always divisible by 8. So here is our proving process. By factoring this expression, we have 2n plus 1 plus 2n minus 1 times 2n plus 1 minus 2n plus 1 is equal to 4n times 2, which is equal to 8n. And since n is a whole, that's what we're assuming here, 8n would be divisible by n. Therefore, polynomial 2n plus 1 squared minus 2n minus 1 squared has to be divisible by 8 when n is a whole number. So the basic idea is to convert the expression into the product of whole expressions and then analyze its factors. So whenever you're giving a trickier question like this, always think of how you can simplify this expression so that it falls in the form of 8 times something. Class summary. Today we factored with the square difference formula. The formula is a squared minus b squared is equal to a plus b times a minus b. And the steps of doing so is to first remove common factors, apply the formula, and then continue until the polynomial can no longer be further simplified. Now this, the class summary page, is usually a good place to take notes because it sort of concludes and wraps up everything we've covered in this lesson in a really organized way. And it also breaks down all the points for you, which is very helpful in my opinion. So if you do have to take notes, this is a good time to pause the video. In our lesson summary, today we used the square difference formula for factorization, and we factorized polynomials by comprehensively applying the common factor method as well as the square difference formula. Thank you so much for watching through Inquisitive Kids. Again, part 2 to this lesson is coming up soon, so if you would like to be notified for that, remember to hit that notification bell and the subscribe button. Thank you so much for watching our channel. We'll see you next time.